Hello, Assalamualaikum and a good day. So here is the presentation of a chapter 5 which is probability. And here are a few terms that we should familiarize ourselves with, which is experiment is a process by which you obtain an observation. Trials is a repeating an experiment a number of times. An outcome, a possible result of an experiment. Event is an outcome or set of outcomes. Sample space is the set of all possible outcomes of an experiment and always denoted by universal set. And we should always remember that total probability is 1. Here are some symbols that are used in this chapter, which is A intersect with B. And the informal language should be A and B, and the definition of this symbol would be even A and B both occur. And then there is A union B, and the informal language should be A or B, which means that even A or B or both can occur. And this would be the symbol for complement, A apostrophe, which is informal language is not A, and even A does not occur. Conditional, which is A given by B, which even A given that even B has occurred. And this is the conditional probability, and this formula is given in the formula booklet. And these are some possible formula that could be derived from the formula according to the question that are given.
Next, I'm going to explain on the two diagrams that can be used to represent probability. The first one is the tree diagram. For tree diagram, we can use the example given to further explain how we can use tree diagram to explain probability. The first one, we have two events A and B. So the first branch, we use probability A, which is the probability of event A happening, and probability A prime, which is the probability of event A not happening. And then we can further the branch by using the event B, which is B, the probability of event B happening, and B prime, the probability of event B not happening. From those branches, we can conclude, for example, in the first branches A continuing to branch B, we can say it is the probability B given A, which because A happens first and then it is followed by B, and then we can apply the same to every other branches. Next is Venn diagram. For Venn diagram, the square one represents the universal set, while the circle A represents the probability of event A, and circle B represents the probability of event B. And for the overlapping section between A and B is the intersection of the probability of event A and B happening, which can be represented by the symbol inverted U. For union, it is the total of probability of both events A and B happening, which can be represented by using the symbol U. And then lastly, for the complement, which is the probability of both events A and B not happening, which is usually represented by using the symbol prime. For example, given that B has occurred, what is the probability of event A to happen? It means that it is probability A given B, where we only look at event B circle and take the probability of event A to happen, which means that in this case, we have to use the intersection.
So for the last part, for chapter 5, we're going to cover the 3 keywords that we always encounter during probability questions. So for the first keyword is mutually exclusive. So from this Venn diagram, we can see that event A and event B does not overlap each other, which means that there is no intersections between both events. So when there is no intersection between both events, it is said to be mutually exclusive. And mutually exclusive also can form complementary event. For the second keywords, we're going to talk about independent event. Independent event is meant by the probability of getting event A does not affect of probability on getting event B. So from this Venn diagram, we can see that A and B overlap each other. So to prove that it is an independent event, we must show that the probability of intersection between A and B is equal to the probability of A happening times with the probability of getting B happening. So for the last keywords, it is exhaustive event or complementary event. The meaning of exhaustive event, it is an event that complement all sets of data, which means that the probability of getting event A and event B happening must be equal to 1. So independent event does not equal to the exhaustive event, but all mutually exclusive are exhaustive event.